BSc Electronics. Today's video is the previous year question paper discussion for IPRC Technical Assistant. That is the examination for IPRC location, that is ISRO Propulsion Complex Technical Assistant. Examination is going to happen very soon. The location is Mahendragiri. Okay, so today we are going to see the previous year question paper of 2018 IPRC Technical Assistant examination. Okay, so if you analyze a question paper, the questions are very simple. So the cutoff probably was more than 90% because the question is very simple and some basic and tricky questions were only there. Okay, so let us see what are the questions. So if you are preparing for IPRC examination, you should watch this video till the end. Okay, so this is a part 1. We'll do part 2, part 3 and till all the 60. There were 60 questions total. There were 180 marks. Okay, so we'll do all the questions. This is a part 1 and let us see what is the first question. In a full wave rectifier without filter, ripple factor is dash. This is a very basic question we have discussed in a lot of previous year videos. You should know the ripple factor for half wave and full wave. You should be thorough with this number, because I've seen a lot of question papers asking this question. For a full wave rectifier, the ripple factor is 0.482 is a ripple factor, and for full wave, for half wave it is 1.21. Okay, please note this down. This is very important. Okay, you may not be knowing all the theory of rectifiers, but you should at least know the ripple factor, because this is very important. For a full wave it is 0.482 and for half wave it is 1.21. Moving on to the next question. In a AC circuit, R and L are in series, what relation is true? Okay, so this question is analyzing about the relation between the voltage and the current in R and L. Okay, let me read the options. The voltage across the inductor and the current through the inductor are in phase. Option B, the voltage across the inductor lags the current through the inductor by 90 degree. C, the current through the resistor lags the voltage across the resistor by 180 degree. Option D, the voltage across the resistor lags the voltage across the inductor by 90 degree. So for you to be familiarized with this concept, let me just draw the diagram of current and voltage for the resistor and inductor. Okay, so the relation, that is the voltage relation between the resistor and the inductor, that is, this is BL, voltage across inductor, this is VR, this is the total VT voltage, and this is the relation. So if this is this diagram, this arrow indicates this is a phasor diagram. Okay, so this indicates the VR or voltage across the resistor, then this is VL. So this angle is nothing but 90 degrees. So from this it is very much clear that the voltage across the resistor is lagging 90 degree behind the voltage across the inductor. So which option is correct? Option D is correct. That is, the voltage across the resistor lags the voltage across the inductor by 90 degree. You don't have to mug up all this. Just remember this graph. Okay. So this graph indicates the relation between the VR and VL. This is the total voltage VT. Okay. This is a resultant. Okay. So this is a relation. Don't mug up all these things. Just remember this graph. Correct answer for this question is option D is the correct answer. Moving on to the next question. Okay, let me just remove these options and question in order to make some space to write. Okay. So there were a lot of basic theory questions in this question paper. So if you're preparing for technical assistant, you should practice network problems and circuit problems, but you should be always very much thorough with the core concepts. Okay. So moving on to the next question. Which component opposes the change of voltage? This is a very basic question. This is asking the components, about the components. We know the basic components are capacitors, resistors, inductors, and out of which capacitor is that component which opposes the change in voltage. We know that capacitor stores charge, and we know the relation Q is equal to CV. So this So this capacitance is actually nothing but the storing of charge, right? So for that, voltage should be constant, or this component is actually opposing the change in voltage. Okay, so the correct answer is capacitor. This is one of the basic theories of capacitors. It opposes the change in voltage. Next question. What happens when heat is applied to the joined ends of the wires of a thermocouple? Okay, so the basic structure of a thermocouple is like this. There is a voltmeter. There are two compound wires. These wires are generally compounds. It is mixture of two or more metals. Chromel. There can be various metals. Alumel. So these are some compounds. This is a joined end. So the question is, if you apply some heat to this point, that is a joining point of a thermocouple, this is a thermocouple, what will happen? The answer is a slight voltage will be generated. So that is a working principle of a thermocouple. So thermocouple is used for measuring the change in temperature or temperature variation it affects, and temperature variation is affecting the thermocouple, and as a resultant or as a result of this temperature variation, a minimal voltage will get generated. The answer is from the options. It is very easy to figure out from the options also. The options are were not really confusing. The answer is a small voltage is generated. Next question. If a gas in a fixed volume container is heated, the pressure of the gas will dash. When gases is generally heated, the pressure is not, it is increasing, not decreasing. So when the gas is filled in a fixed volume or a fixed size container, fixed volume container, the pressure will get increased when it is heated. Okay, correct answer is, the options can be increases, decreases, or it remains constant. Answer is it increases. Okay, next set of questions is this. So you need to find the output of this circuit. So this is nothing but an operational amplifier, and if you see the input is connected, that is this terminal A is actually the input. Output is B. You need to find how the output waveform will look like. So for the case of an inverting amplifier, we know that the input-output relation is 180-degree phase change is there. Due to the inverting, that when input is applied to inverting terminal, it inverts the output. That is why it is called inverting terminal. Whereas if it is applied to the positive terminal, they are in phase. Okay. So if if this is your input waveform, your output waveform will be 180-degree change in phase. So it will look like this. Okay. So we'll draw it here. If this is A, your output B will look like this. 180-degree phase change will be there. Okay. So this is the output for a inverting amplifier. So from the option you have to choose this graph of this waveform. Next question. So first you have to identify that this is the inverting amplifier because your input is applied to the negative terminal. So there is a phase change for the output. If this is A, this is B. Okay. Moving on to the next question. If 2.25 microfarad capacitors are connected in series, the effective capacitance is dash. Okay, so here we are going to connect two capacitors in series. Let it be C1 and C2. What is the relation for the effective capacitance? C effective is equal to 1 by C1 plus 1 by C2. And if these capacitors are connected in parallel, C1, C2, then C effective is equal to C1 plus C2. This is the relationship you should study in order to answer these type of questions. Anyway, this is also very simple. That's why I have not written the options also. Okay, so for series connection in case of capacitance, unlike from the resistors, the relation for effective capacitance C effective is equal to 1 by C1 plus 1 by C2. For parallel case, it is C effective is equal to C1 plus C2. So here we are talking about nothing but series connection. So C1 or C effective is equal to 1 by C1 plus 1 by C2, or you can write this as C1 C2 by C1 plus C2, right? So what is the value of C1 and C2? Both are same, 0.25 microfarads. Okay, so it is nothing but 0.25 into 0.25 by 0.25 plus 0.25. Okay. So 0.25 plus 0.25 is nothing but 0.5. If you solve it, you will get 0.125 microfarads will be the value for effective capacity. Power factor of a circuit is equal to dash. Options are EI cos theta, B cos theta, C EI sin theta, D sin theta. The power factor of a circuit is cos theta is the power factor. Okay. So cos component or cos theta is always contributing to the power factor of a circuit. Correct answer is option B, which is cos theta. Next question is actually very simple question. Energy is the capability or ability to dash. Energy is the ability to do work. Okay, so the options is also very simple. You should be able to figure out from the options also. Energy is nothing but the ability to do work is called energy. Next question, what does LED stand for? So these are very basic questions. So that's why I've told that the cutoff should have been more than 90%. Okay. So if you are preparing for IPRC location, you should always be thorough with these core concepts, core questions. Some of the important areas are there. From each, you don't have to mug up all the theories. You have to pick out these important points. Okay. So what does LED stands for? LED is nothing but light emitting diode. LED is light emitting diode. Light emitting diode. So everybody is knowing this. This is the symbol of a LED. I'm even telling you the symbol. This is the light emitting diode. There is a basic diode which is emitting light. This is a symbol for a LED. Okay. When relative permeability is much greater than 1, it's called a dash material. So we know that there are various magnetic materials, diamagnetic, paramagnetic, ferromagnetic. So these are the various type of magnetic materials based on their magnetic properties or based on their relative or permeability. Okay. So if the permeability, that is a relative permeability, if it is much greater than 1, and then it is called a ferromagnetic material. These ferromagnetic materials has spontaneous magnetization. They will get magnetized very faster. So they have a relative permeability. They are generally we are saying it's a relative permeability, not its permeability, but relative to the material. Its relative permeability is much greater than that of 1. So these type of materials are called ferromagnetic material. Now, what is a diamagnetic material? These materials are generally repelled by the magnetic fields or repelled from the magnetic fields. And its permeability, not relative permeability, its permeability is slightly less than 1. So, that is the case for a diamagnetic material. Now, moving on to the paramagnetic materials. Its permeability is only slightly greater than 1, but it is slightly greater than 1, and they are having weak magnetization. So that is the case for a paramagnetic material. They have only weak magnetization, whereas the case of ferromagnetic material, they have high magnetization or spontaneous magnetization, and its relative permeability is much greater than 1. So these are the 3 types of materials, and this is how their permeability varies. This is slightly less than 1, this is slightly greater than 1, this is much greater than 1. Moving on to the next question. In a simple DC circuit with a constant voltage, when resistance increases, current will decrease. So when voltage is constant, resistance increases means current will decrease. Okay, decrease is the option. Next question. In a N-type silicon, each donor atom contributes dash electron. Each donor atom will contribute 1 free electron for the case of a N-type silicon. So we know that in N-type silicon, we are adding donor impurities, and each donor impurity contributes 1 free electron. Okay. Next question. We have to identify what is this circuit. Okay, so this circuit is consisting of an operation amplifier, and there is a feedback connected to the negative or the inverted terminal from the output side. So this is nothing but a voltage follower. So what is actually a voltage follower? Voltage follower means here there is no amplification of your input signal, whatever signal is being applied to the input side, it follows the output follows the signal on the input side. There is no amplification of the signals. Such circuits are called voltage follower circuits, where the output follows your input. Okay, so if this connection is seen, it is nothing but a voltage follower circuit. The frequency of oscillation of a tuned collector oscillator having L, inductance is 30 microhenry, and C, capacitance is 300 picofarad is dash. Okay, so the equation for the tuned collector oscillators tank circuit is, or the frequency of oscillation F is given by 1 by 2 pi square root LC. Here L is equal to 30 microhenry, means 30 into 10 raised to minus 6 Henry. You have to substitute this value, 30 into 10 raised to minus 6. And C is equal to 300 pico, means 10 raised to minus 12 farads. So this is the values you have to substitute in this equation. The equation is 1 by 2 pi square root of LC. Please have this equation. The answer obtaining is option B, 1677 kilohertz will be the frequency of oscillation. Next questions are very, very simple questions. First question is the width of the depletion layer in a PN junction dash. The question is actually asking you how the width of the depletion layer varies with the forward or the reverse bias. We know that the width of the depletion layer is always affected by the reverse bias potential. So when this reverse bias increases, the width will also get increased. So the answer from the options is it will increase with the increase in reverse bias. Okay, so whenever reverse bias is increasing, depletion width is also increasing. Next question, valency electrons or valence electrons are the dash. Valence electrons is actually the electrons which are present in the outermost orbit of a atom. Okay, there is inner nucleus, then there are various shells, we know that K, L, M, N, and outermost orbit there are certain loosely bound electrons, and these electrons, these are basic physics things. Okay, so we know that these electrons are called the valence electrons. Next question, the process of adding impurities to the semiconductor is, there can be various twisting options, but you know the answer is doping. We dope we dope impurities, donor impurities and acceptor impurities. And by adding of donor impurities, we get N-type. By adding of acceptor impurities, we get P-type extrinsic semiconductors. Okay, so the process is called doping. The next question that we are going to discuss is this. The configuration in which the current gain of transistor amplifier is lowest. In which of this configuration, that is common base, common emitter and common collector, which configuration has current gain lowest? Current gain is lowest for common base is the correct answer. And also I have given you a chart for you to study it very easily. That is the relations of current gain and voltage gains for common base, common collector and common emitter. So if you see, the current gain is highest for common collector, and if current gain is high, the voltage gain should be low. Okay, so for the common collector, current gain is highest for common collector, it is low for common base and medium for the case of common emitter. For common emitter, current gain and also voltage gain is only medium. And common collector is having the highest current gain, and for voltage gain, common base is having highest voltage gain and common collector has lowest voltage gain, and for common emitter it is medium. So it is very easy, you just have to study the highest ones for current gain and voltage gain. So for current gain, highest is for common collector and voltage gain is highest for common base. And if that is the current gain is highest, means voltage gain has to be low. So this is the chart for current gain and voltage gains for various transistor configurations, that is common base, common emitter and common collector. So if you study this or if you note this down, it will be very useful because this relation is also very important. Okay, so sometimes they also may ask for which it is lowest, that is voltage gain is lowest or less than unity. So this type of questions can come because in some question papers, I've seen questions that which of this transistor configuration have the voltage gain lesser than 1 or very low. It is common collector. Okay, so these type of questions you can expect in your examination. Okay, so these were some of the previous year questions of IPRC location technical assistant. So if you are preparing for this location, I hope that this video will be useful for you. If yes, please do give it a thumbs up and also share these videos with maximum of people who is preparing for these examinations. There's a lot of examinations going to happen for technical assistant for various locations of ISRO. Okay, so if you're interested in watching these competitive examination preparation and also generally topic-wise videos of electronics, please do subscribe to the channel, and also please tell your friends to subscribe to the channel. And also if you are interested in watching the recruitment news of electronics basically, and also general recruitment news for BTech and diploma people, please do subscribe to the channel. Thanks for watching and keep on watching.